be impossible. You'd simply sink right through until you were crushed by the intense pressure. Much like going to the bottom of the ocean without a submarine. But if you could stand on Jupiter, you'd immediately experience the planet's powerful gravity, 2.5 times stronger than on Earth. Let's take a healthy 200-pound astronaut and let him experience Jupiter's gravity. He may weigh 200 pounds back on Earth, but on Jupiter, he'd weigh 480 pounds. Now let's put our astronaut onto the surface of Pluto, which has just 1/15 the gravity of Earth. This same 200-pound astronaut would weigh just 14 pounds on Pluto. Floating above Earth, it may seem there's no gravity in space, but there's really no such thing as zero gravity. In fact, gravity is everywhere in the universe. Gravity is what keeps the planets orbiting around the sun. It also keeps matter from coming apart. Without gravity, everything would cease to exist. But there are such places in the universe, mysterious places, where gravity and the laws of physics break down completely. That's what would happen if we were to travel too close to a black hole, as we'll see when we come back. Black holes began to form not long after the Big Bang. They occur when a massive star collapses in upon itself, causing a supernova. Try to imagine an explosion of such extraordinary size and magnitude occurring in virtual silence. Without air to carry the sound, the quiet found in space tempers the power and otherworldly beauty of the birth of a black hole. Unlike sound, light travels through empty space as a wave, carrying electromagnetic energy in it. But there are some places in space where the forces are so potent, stars can be compressed and swallowed. In black holes, the forces of gravity are so strong, not even light can escape. Imagine an ocean liner drifting through space. The movement of stars and black holes produce gravitational waves that draw matter inward toward a deadly, inescapable whirlpool of energy. Get too close to a black hole, and the gravity becomes too strong to overcome, even for masses as large as stars. To escape that kind of gravity, you would need a speed greater than light. In other words, there is no escape. Our ocean liner wouldn't stand a chance. NASA has already begun to explore the universe with satellites and space-based telescopes that search for massive black holes and other astronomical phenomena. But what might it be like if one day we could mount an expedition to see firsthand one of these cosmic mysteries up close? scientists have discovered many black holes in the Milky Way. If they are big enough, they can capture nearby stars, planets, and even smaller black holes. How many there are, no one really knows. Perhaps billions. Any future explorers hoping to get a closer look at a black hole will have to keep their distance. Otherwise, the extreme gravity will act like a giant invisible hand, reaching out and pulling them in, bringing a fatal end to their voyage. Once a spaceship or a planet reaches what's known as the event horizon, there is no turning back. In smaller black holes, forces of gravity are stronger toward the center. As objects draw closer to the event horizon, they would be stretched into long, thin shapes. Their matter would then be ripped apart. Here's how it works. Suppose NASA launched 3 exploratory probes to study a black hole. They would be able to record data and send it back right up until they reach the event horizon. At that point, the probes would undergo what scientists call spaghettification. It would occur in the microsecond before they were obliterated. Here at the event horizon, light bends and photons are trapped forever. It's a place from where nothing can return, and all known laws of physics cease to exist. Not even the forces or the light from an exploding star could escape. Neither man nor machine would be able to relay back what happens next. If we were able to take one last look at our universe, how long might it be before everything we knew seemed to shrink away into darkness? Deep inside this prison is said to be a place where photons pool, where hellish temperatures can reach 20 million degrees and neutrons melt. If only some of the light could be reflected back, what would we see? Einstein's theory of general relativity allowed for a space-time curvature to connect 2 distant locations through a theoretical tunnel known as a wormhole, a shortcut through space-time. Could it be possible that wormholes are the bridges and doorways between different places in our universe? Could they one day be used for travel, like a tunnel through a mountain? The forces in our universe are extreme. When we come back, we'll show you a preview of how the universe ends. Don't worry, we won't be around to see it for ourselves. Launched in 1990, the Hubble Space Telescope orbits the Earth, and for decades, it's been beaming back images that are helping scientists unravel some of the great mysteries of the cosmos. Inside Hubble are multiple cameras. Some of these cameras are so light-sensitive that they would be destroyed by taking a picture of a star that's visible to the naked eye. These are the cameras used to peer deep into space at the faintest stars imaginable. The oldest light to arrive at the Earth. Beginning in 1995, Hubble began to capture deep field images in space, revealing thousands of galaxies. By peering so far into the distance, Hubble was also peering far, far into the past. It's a past that can actually tell us a lot about our future. The universe may have begun with a Big Bang, but there are several scientific theories predicting its demise. Will it all end in a big chill, a big rip, or a swirling mass that condenses into a big crunch? Let's start with the most peaceful theory, so we can get used to the idea of everything in the universe finally coming to an end. Then we can work our way up to the sheer terror scenarios. One theory has the universe expanding forever, with galaxies drifting further and further apart from each other. This is known as the Big Chill theory. Over time, long stretches of time, stars would begin to lose their energy. They would die out, one by one, the sky turning darker and darker. The universe would continue to expand, slowly but never stopping, until it would become a very cold and dark place. Earth would suffer the same fate. The light and heat it receives from the sun would, over time, diminish. Our magnificent sun will eventually use up all of its hydrogen and expand into a red giant before burning itself out. Eventually, the universe, like Earth, would end in what scientists call the Big Chill. For reasons unknown, since the Big Bang, the universe has been expanding at a faster and faster rate. Astronomers attribute this continual expansion to the presence of dark energy. We don't know much about it yet, but scientists believe that 70% of the universe is comprised of dark energy. Einstein was the first to realize that empty space has properties, and he predicted that empty space can also have its own energy. This brings us to our second universe-ending scenario. If you thought the Big Chill was bad, you may want to close your eyes for this one. As more and more space is created, there becomes more and more dark energy, causing the universe to expand faster and faster until gravity is completely undone.